Previously, we've mentioned that programmers could handle exceptions in their programs. The question is what type of exception? In other words, what is the class of exception that we should handle? We've mentioned that programmers should handle the exceptions that are instances of classes that are derived from the exception class. So this is the name of the superclass of all exceptions that occur in our programs, such as arithmetic exception, array index out of bounds exception, and input mismatch exception. All of these are descendants of the exception class. So exception is their superclass. So therefore we can combine all of these exceptions and catch them in one catch statement. So let me show you in our program how to catch all of these exceptions under one catch using this type of exception. So what we will do now, instead of assigning a catch statement for each exception, we can combine them all in one catch using only one class of exception that is called exception. So let us do that. So now here we will write exception, E capital letter, and we will remove all other catches statements. And inside the catch statement, we are going to use getMessage method to print the message that is already assigned to the object when the exception was created. So let us display this message. Simply we say here exp dot getMessage. So let us run the program now and see how the messages are displayed by each of these exceptions. So now we run the program. Let us try the first exception, which is arithmetic exception. Let us try the first exception, which is arithmetic exception, by entering 2 as an index, and see now this is the message displayed by the exception generated when divided by number. So this message in fact was inside the object of the arithmetic exception, but it was accepted by the class exception, because exception is a superclass for all these types of exceptions that we have covered so far. Let us run the program again. And now let us try array index out of bounds exception. So here we will say 12 as an index, and we don't have a 12 as an index. And this is the message that is displayed by the exception generated when we access the array with an index out of bound. So the message index 12 out of bounds for length 9. Now let us see for the last exception when we enter double instead of integer. And here we will say 3.5. So nothing is displayed. So in this case, this catch is not suitable for such type of exceptions because no informative information is displayed to the user. Therefore, you have to take this exception by yourself and display a message. And since all of these exceptions come into one place, then we cannot differentiate which type of exceptions that we have received in the catch statement. Therefore, we need to add another catch for input mismatch exception. But order is important if you have multiple catches, because exception is a superclass for input mismatch exception. So you have to catch this exception before its superclass catches the exception. So let us do it. And now here we write catch, and we will say input mismatch exception, and the object name will be exp, and inside we are going to display a message because getMessage will not give us any useful message. And here we will say system.out.println, and we will say index should be an integer. Well, let us run the program now and see what happens. So now if we give an index 3.5, then this exception has been caught by input mismatch exception before its superclass exception. Now let us change the order, and instead of catching input mismatch exception first, let us try to accept it as a second exception. And we will write it after catching the exception, which is the superclass for input mismatch exception. Now if we try to run the program, and now here we have a syntax error. It says that exception input mismatch has already been caught, because order is important when we have multiple catches. So whenever your program throws multiple exceptions, then you must have multiple catches. so that every exception must be caught before it is caught by an exception of its superclass type. In all of our previous examples, exceptions that we were caught were objects created from predefined exception classes in the Java API. API stands for Application Programming Interface. As previously mentioned, every exception in a Java program is an object, and these objects are created from the classes that are defined in the Java API. The API has an extensive hierarchy of exception classes. A small part of the hierarchy is shown here. In other words, every exceptions thrown in our programs are in fact instances of the classes shown in this diagram, or of subclasses of one of these classes. For example, the arithmetic exception that we have introduced in the previous examples is a subclass of runtime exception class, and the runtime exception class is a subclass of exception, and so on. Now suppose you want to catch two exceptions and one is a subclass of the other exception. For example, the arithmetic exception is a subclass of the general exception. And if you want to catch these two exceptions in your program, then make sure to catch the exception that is a subclass of the other one. So you have to catch the arithmetic exception before the general exception. Otherwise, you are going to get a syntax error. And we have seen this in a previous example when we try to catch a general exception before catching the input mismatch exception, and we've got syntax error. So you have to catch first the input mismatch exception because it is a subclass of the exception, then you catch the general exception. In fact, Java includes two basic classes of exceptions, the error class and the exception class. All subclasses of the error class are for exceptions that are thrown when a critical error occurs, such as running out of memory. So your applications should not try to handle these errors because they are the result of a serious condition. However, all the exceptions that our applications should handle will be subclasses of the exception class. The two of these subclasses, in fact, are input-output exception and runtime exception subclasses. The input-output exception class serves as a superclass for exceptions that are related to input and output operations. And runtime exception class serves as a superclass for exceptions that result from programmer errors, such as an out-of-bound array subscript. For input-output exception, we are going to talk about it in more detail when we talk about files. For example, if we try to read from a file that does not exist, then the program will generate a find not found exception. Now suppose your program has an error other than input-output error, and you want to raise an exception. Which exception that you have to use from the Java API? If you know the type of exception, simply throw an object of this exception. Otherwise, you can throw a general exception that is an object of the superclass exception. And this is what we are going to do for our examples. We would like to show you some examples that are subclasses of the exception class. In the first example, we will show you how to throw and catch an exception in the main method only. And in the second example, we will show you how to throw an exception in the constructor of a user-defined class and how this exception is handled in the main method when an exception is thrown by an object created from the user-defined class.